In. Hello cadets. Now let's continue further the various types of image formations in case of a concave mirror. The next object position is when the object is between F and C, that is between the focus and the center of curvature. Now in this case, when the object is placed between focus and center of curvature of the concave mirror, the image is formed on the same side as that of the object. It is real, inverted and magnified. Okay. So now because here you are going to get a magnified image, so obviously object that you are going to draw here should be a bit smaller. Okay. So wherever magnification is larger, image is bigger than the object, draw smaller objects. Second thing, for this, if you move the object away from the center of curvature and towards the focus, okay. So previous diagram, if you remember, object was at C, image was also at C. Now imagine you are moving the object towards focus. What will happen is, first the image, of course it will be real and inverted and of course magnified as well, but it will be moving away from the center of curvature and for that matter away from the concave mirror also. So if you draw object closer to the focus, if you draw it closer to the focus, the image will be much far away from the mirror. And that is the reason that for this ray diagram, another precaution you have to take is that draw the object closer to the center of curvature and a little bit away from the focus. So of course the object is between F and C, no doubt about that, but it should be closer to C and a little bit away from F. And because the image obtained is magnified, we are going to draw the object a bit smaller. So this is your object. Again, as usual, the two rays of light, first parallel to the principal axis. After reflection, it passes through the focus, extended backwards. Second ray of light passing through the focus, and therefore after a reflection, it goes parallel to the principal axis. So after drawing these two reflected rays, wherever those rays are going to be intersecting, at that point you are going to draw the real and inverted image. So here at this point, these two reflected rays are going to intersect, and so we are going to draw the image here, and obviously it does look bigger than the object. Okay. If you draw the image or object, if you draw the object closer to the focus, in that case, the image, of course, it is going to be far away from the center of curvature and the size of the image is going to be much bigger. So in a way, you can also state that as you bring the object, which initially it was at infinity, if you bring it closer to the mirror, as long as you do not touch focus, that is, you are still behind the focus. Okay, so object is at infinity and you are approaching the mirror, you are bringing the object towards the mirror, the image will remain real and inverted, but the size of the image will go on increasing, and at C, when the object is placed at center of curvature, the size of the image will be same as size of the object. When you cross the center of curvature, the image is going to be magnified larger than the object. Now, when you place the object exactly at the focus, we say object at F at focus, image at infinity. Now, what exactly is the meaning of this first? Okay, so let's first finish the ray diagram, then we will go into the details. Now here, you are at liberty to draw any two rays of light. Like first somebody will say, okay, I want to draw this ray of light at the pole and the other ray of light which goes parallel, and after reflection it passes through the focus. So this ray of light also can be drawn, but there is one ray of light that you will never be able to draw in this image formation, and that ray of light is the one that passes through the center of curvature. For this case, you cannot draw that ray of light. Okay, so best option, first incident ray, draw it parallel to the principal axis. After reflection, it will pass through the focus itself, and second ray of light, the one that is incident at the pole, after reflection, it will go like this. Now, what happens here is both of the reflected rays are parallel to each other. Now, an important property about parallel lines that we know from geometry is that we usually say two lines are parallel because they intersect at infinity, or two parallel lines intersect at infinity. Okay, very much like that. Consider this these two reflected rays. So both of the rays are parallel to each other. Obviously, they are going to intersect at infinity. They are going to intersect at infinity. And that is the reason that here we say object at focus, image at infinity. Now, another important point here is that the magnification is going to be very high, very large in magnitude. Although we do not define the magnitude of magnification here, but it's a point of understanding. It's a matter of understanding that in this case, magnification is going to be very high. Why? Just now we saw, as we move object towards the focus, the image moves away from the mirror, but the size of the image goes on increasing. It goes on increasing. So when you are exactly at the focus of the concave mirror, no doubt the image will be at infinity, but it will also be infinitely larger, very, very large compared to the actual size of the object. Okay, so thus far we have discussed and drawn the ray diagrams involving real image formation. That is, in case of concave mirror, the conditions in which real images are obtained. Okay, now one or two important points about the ray diagrams. First, always mark object and mirror by arrows. So these arrows mark or show the relative orientation of the object and image with respect to each other. So if you just look at this ray diagram, you will realize the object is erect, image is inverted. So just to show whether the image is erect or inverted with respect to an object, the object and image both must be marked by arrows. So arrow shows their orientation. Second point, in every ray diagram, incident rays and reflected rays must be represented by arrows. Incident rays and reflected rays must be represented by arrows so that they are distinguished. They are not confused with other straight lines that are there in the diagram, particularly the principal axis. Okay, third important point, wherever real image is formed, you draw that image using a dark line like this. So this line is dark, that means this is a real image. Wherever virtual image is obtained, you always draw a virtual image in the form of a dotted line, somewhat like this. Vice versa, if you have been given a ray diagram in which the image is drawn like this, then it clearly means that it is a virtual image. But remember, real or virtual, the image must be marked with arrow, and if it's a dark line, real image. If it's a dotted line like this, it's a virtual image. So you can use all these points and properties as guidelines for drawing a ray diagram, or you can also use them to read, analyze and interpret a given ray diagram. So you might be given a ray diagram in the question or the question paper. So you can use all these points to interpret that particular ray diagram. Okay? Okay. Thank you very much.